So this is Mastering Physics, Chapter 3, number 41. And the problem is, a jet plane is flying horizontally with a speed of 570 meters per second over a hill that slopes upward with a 4% grade. This means the rise is 4% of the run. What is the component of the plane's velocity perpendicular to the ground? So as you can see, I've started with a diagram. Here's the idea. The jet plane is flying horizontally, so start with that vector. That vector v is horizontal. Now, the idea too is that the plane is flying over a hill that slopes upward. So here's the hill that slopes upward, and I've given the slope an angle alpha. Now, that defines our coordinate system. That if I define the x-axis to be along that slope, I've shown over here my x-axis, and then the y-axis is perpendicular. From there, you can draw components. That the component of the velocity parallel to that slope, I'm going to call that v parallel. Perpendicular to that component, v perpendicular, is in the direction of the y-axis I've drawn. So now solve. They told us that the hill slopes upward with a 4% grade. The rise is 4% of the run. So we'll go ahead and translate that into the angle alpha. That means that alpha is going to be equal to the inverse tangent of 4 over 100. That's what a 4% grade means. So, if we do the math, we get 2.3 degrees. Now to find the perpendicular component, we've labeled v sub perpendicular. That's going to be equal to v times the sine of alpha, where v is this initial velocity vector we drew in the diagram. And if you plug in the details, you get 570 meters per second times the sine of 2.3 degrees. So that's going to be equal to 22.9 meters per second. And to be totally clear, that component is in the negative y direction. Remembering that we defined y up here to be perpendicular to the x-axis we drew along the hill that slopes upward.